All right, well, good morning, and thank you for attending the virtual Idaho Potato Conference. Mike Thornton's presentation was the perfect segue into this presentation. But before I begin, I wish to acknowledge the numerous contributors to our program, looking at factors that impact development of bruise. Specifically, Mike, Rebecca Hendricks, Lynn Waddell, Tyler Spence, all from the University of Idaho, and then Jeff Miller and Miller Research. Our experience evaluating quality losses over the past several years points to the primary association with either a direct impact, black spot bruise or shatter bruise, or an indirect impact, meaning that the direct impact caused subsequent loss due to soft rot, dry rot, and potentially even pressure bruise. Having this strong association prompted us to focus our research efforts at these direct impacts of shatter bruise and black spot bruise. Initially, there must be a physical impact for bruise to occur. Emphasizing, minimizing drop heights, padding equipment, raising stingers are all part of the equation to minimize that physical impact. But we must move potatoes around on a lot of pieces of equipment, and physical impact is unfortunately inevitable. One option to identify those physical impact risks is to use some sort of detection method, such as here using an impact recording device as a management tool. It allows you to identify the force and velocity of a physical impact, and then allows you to modify equipment and lessen the risk for bruise. As an example, we dropped the impact recording device onto 4 different materials. A max G of 80 to 100 is about the threshold where a bruise may occur, the black line. The red line indicates if you drop a potato onto a potato, you may not see a bruise until a drop of 14 inches, which is why the recommendation is to keep chains and belts full with potatoes. But if you drop it on an unpadded chain, the purple line, or shown in the picture, it only takes about a 2-inch drop to cause a bruise. Overall, it is not only drop height to be concerned with, but the material it drops onto that can also cause a bruise. That is one reason you will hear us stress about padding equipment and looking for any area that may create a greater risk for a physical impact. Yes, you need a physical impact to cause a bruise, but we also know that the potato will vary in response to that physical impact based upon its physical and physiological characteristics of that potato. It becomes a very complex matrix regarding which components will impact susceptibility. Some may even contradict the other. Regardless, the potato contribution to bruise is complex and one, as many others before us, have set out to research. One initial question we had related to the quality project Mike described just recently was that what is the timeline of when those quality losses are occurring? How are we not seeing initial problems in the potatoes, but later problems show up? This led us to look at how quickly will a bruise occur or appear? Well, for shatter, it is immediate. We have developed a quick tool of using a dilute iodine solution soak to color the shatter bruises and make it easier to see. You can easily see the black-blue discolored shatter bruises in the upper right-hand photo. But for black spot bruise, it takes time after a physical impact for the biochemical process to occur and cause that darkening color. That creates a major disadvantage when needing to adjust conditions and equipment and not having the luxury of time to wait up to, let's just say, 24 hours before samples can be peeled and evaluated for black spot. Now, warmer temperatures do help. They will speed up the process, such as using a hot box. But we also wonder how quickly will you see a bruise from unloading a storage prior to processing and packing? Is that contributing to some of these defects that we're seeing? So to look at this, graduate student Rebecca Hendricks bruised 3 different varieties, Russet Burbank, Russet Narcota, and Ranger Russet, at 2 different drop heights, 7 and 12 inches, essentially 2 levels of impact forces, and then evaluated over the first hourly, over the first 5 hours, and then after 24 hours, as potatoes were held at room temperature of 70 degrees. Now, a few things to take away from this project. Differences between stem and butt end. Stem end has higher bruise potential and the bud end was slower to develop black spot bruise than the stem end. This is easily seen in the Norcota, the black line being the bud end versus the gray line, the stem end, much higher in development, overall development, and much faster to develop. We also see differences in drop heights. They're apparent in not only over the overall incidence, but time to development is similar between that, as seen in the yellow and the gray lines in rest of Burbank. Yes, there's differences, but the overall trend over time is the same. There's differences in hours. Now, generally, the general trend is that you will see the majority of the bruises, let's just say over 80% of the overall bruises, develop within the first 5 hours for both Norcota and Burbank. Range of susceptibility is so much greater that you can pick up on the majority in just 1 to 2 hours, as seen by these lines, these gray and yellow lines over here. So what does this mean? Evaluating for black spot bruise within 5 hours can be a useful tool to getting closer to being able to make equipment and management decisions on the fly. It takes some time to sample and peel, but the feedback can be very beneficial to those adjustments to make that bruise-free mark. Note that in the first few hours, some of the bruises show more of that pink discoloration, which again can be helpful since it is still relatively easy to see, but after about 5 hours, the bruises are predominantly brown and black. Those results, we're looking at black spot bruise development when holding potatoes at 70 degrees to hasten that bruise development so we can see it sooner. But what about when you're hogging out potatoes and they're kept at lower temperatures? Will you still see that bruise development in that same time period? So instead of holding the potatoes at 70 degrees after bruising, Rebecca held russet Burbank at 48 degrees and also added a 48-hour evaluation. Overall, the bruise development was slower at 48 degrees compared to those warmer temperatures of 70, and shows predominantly a pink and brown color bruises in the first few hours. But still, about 80% of the bruises are showing up by about 5 hours, although about half of them at this point are still pink colored. There was no differences between 48 and 24 hours. This type of data would help us identify if new bruises are showing up after hogging out of storage and if it is contributing to quality issues at the plant or packing shed. So what about those bruises that occurred at harvest? What happens to that bruise with time in storage? Does it get worse? Does it stay the same? Does it get better? So these are two graphs that are showing bruise incidence. One on the left is black spot, on the right is shatter bruise. All these potatoes were bruised at harvest and then placed into storage. We'll start with black spot bruise incidence. Overall, Burbank had a higher incidence compared to Norcota. Now this line is combined for both Burbank and Norcota. There was an increase of about 20% incidence of black spot bruise from harvest to the first month in storage, but after that, it remained constant. There was also no extreme change in the severity of bruise. Interestingly, when you break up the data and look between bud and stem end, it showed the bud end had a lower incidence of bruise at harvest, but the stem end was constant from harvest on with no significant differences between months. The bud end is known for not bruising as severely and takes more time to develop than the stem end. But it is interesting that the stem end did not change with time. Now on the right graph is shatter bruise. Burbank had higher shatter bruise compared to the rest of Norcota, and the bud end had higher incidence than the stem end. Now this line again is Burbank and Norcota combined. To be expected, there were no differences with time and storage of shatter bruise. So overall, we may see a slight rise in black spot bruise from harvest and the first month in storage, but don't anticipate major changes with bruise with time in storage. Now, what about the susceptibility of the potato as it's removed from storage, handled, and packed? Does this response change with time in storage? So these potatoes were bruised each month to assess susceptibility to handling at various times of the year. Burbank and Norcota were not significantly different overall, but they did respond differently at harvest at that September time. Norcota showed less initial bruise compared to the rest of Burbank. Now, this is picking up on observations and previous data that Norcota is less susceptible to black spot bruise than Burbank. But perhaps it may be transient and observed primarily at harvest, since after harvest and throughout storage, Norcota responded similarly to Burbank. Now, additional studies are in progress to look at this further. Here's the response each month to the shatter bruise. Russet Burbank becomes less susceptible to shatter with time in storage, whereas Norcota showed a lower overall level and a consistent response to shatter with time in storage. Potatoes handled in late storage have a similar risk of shatter bruise as if handled early in storage. This data gives us insight and tools on how bruise is acting either hourly or over time. We have not yet addressed some of the specific contributions from the potato. As we put this data in context with previous research, we're trying to identify which components of the complex bruise pie may play a larger role or larger slice of the pie in the risk for bruise. That will allow initial management to target those larger pieces and then fine-tune bruise mitigation programs with the smaller pie pieces. So far, the three largest factors we have found are physical impact, force, variety, and pulp temperature at times of bruising. But we continue to look at the other slices. The contribution of variety and impact can be significant. Each variety has an inherent level or risk to bruise, and bruise management programs need to be tailored to each variety. Now, Rebecca focused on the interaction of impact force, physical impact force on 6 different varieties. She bruised each variety at 3 different heights. First, this data is showing an overall average how black spot bruise incidents vary between varieties. Clearwater Russet, Dakota Russet, and Ranger Russet had higher susceptibility, let's just say, than Teton and Russet Burbank. But once you start to break it out by drop height, things start to change a little. Clearwater Russet and Dakota Russet are still sensitive to black spot bruising even at that lower drop height. In other words, we're going to have to baby them along a little more compared to, let's just say, Burbank and Teton Russet, which responds well to minimizing those impacts and resulting in less bruise. Now, looking at shatter bruise, this data shows that overall the varieties reacted similarly, except Dakota Russet was less susceptible to shatter bruise. But again, when you tease it out by drop height, you start to note differences in response by variety. Dakota Russet still showed lower susceptibility even with those larger impact forces, whereas the others are showing variation in the response, such as Teton Russet. It really does emphasize the impact force and its ability to cause shatter bruise. So looking at the larger contribution, or again, the bigger slices of the pie, of the bruise pie, variety and force of impact can alter shatter bruise up to 30% and black spot bruise up to 45%. Now, what about temperature and variety? We spent a lot of time talking about recommendations on harvest pulp temperatures that need to be between 45 and 65 degrees to minimize the risk of bruise, disease, and other issues that can occur when outside this recommended range. But this range is not set in stone. These lines are wiggly and not absolute, and we will need to vary it by conditions and variety. So the impact of temperature on black spot bruise can be significant depending upon the variety. Again, there are differences between varieties, but see how each variety responds differently to the various pulp temperatures at the time of harvest. So for Burbank, Teton Russet, and Umatilla Russet, the colder temperatures, the yellow bars, significantly increased the risk for black spot bruise. Whereas Bannock, Clearwater, and Payette Russet were all highly susceptible to black spot bruise regardless of temperature. Now, this just reemphasizes that cold temperatures increase the risk and incidence of black spot bruise. And cold temperatures also increase the risk of shatter bruise, as seen by the higher yellow bars for each of the varieties shown. Varieties that are susceptible to dry rot decay, such as Clearwater Russet, need to avoid colder temperatures at harvest to minimize the risk of shatter bruising. So again, looking at that larger contributions or the bigger slices of the bruise pie, variety and pulp temperatures can alter shatter bruise up to 40% and black spot bruise up to 30%. So impact, variety, pulp temperatures may be the greater contributors to bruise, but it does not negate the contribution of these other factors, nor does it explain why it makes the potato more susceptible. So a 3-year study, collaborating with Miller Research, we looked at the contribution of tuber hydration to bruise. So from vine kill to harvest, plots either received no irrigation, irrigated to maintain about a 75% available soil moisture, or irrigated 1 week prior to harvest. And there was about a 3-week span between vine kill to harvest. There were no significant differences in the incidence of black spot bruise, severity or the depth of the bruise, and the incidence of shatter bruise between treatments in all 3 years. But what we did see between the first year and the other 2 years, differences. And in fact, you can note about a 45% change in incidence of black spot bruise at that time. So we're working at teasing out all this data apart, but one thing we noticed that the crop in the initial year was growing a field with a longer rotation. Initially looking at this data from harvest, we can ascertain that post-vine kill irrigation, specifically in this study, did not dramatically impact bruise, but it is important to not stop at harvest when looking at the potential effects of irrigation and tuber hydration. These potatoes also went into storage. Now, as we were coming up with methods to measure tuber hydration, we noticed these treatments in storage, that the irrigation impacted tuber hydration and response in storage. This may have implications on weight loss and even potentially pressure bruise. So stay tuned for more results from this study. From this irrigation project, we were curious about the impact of maturity on bruise susceptibility, or what else can lead up to harvest that alters the risk for bruise. So for 2 years, each week, starting in August until harvest, Rebecca would dig up plants and measure specific gravity, tuber nutrient content, and bruise susceptibility. What we saw in both years is that black spot bruise susceptibility did not really change until after vine kill. And really, it wasn't that big of a change. There was also no association with specific gravity, at least in these Russet Burbank plots. Now this year, shatter bruise susceptibility did decrease with time, as seen here, but relatively there's little differences in the percentage of, or the incidence of shatter bruise during this time. So tangent research projects like this and others have us wondering more about maturity, fertility, and soil health. And that has led us to a collaboration with multiple experts in the tri-state area to better understand the practices associated with black spot bruise susceptibility. Specifically, we are addressing maturity, nitrogen management, soil health, and measuring these tuber biochemical components that may help us better understand about the potato response and identify useful measurements for identifying the risk for bruise. So again, stay tuned for more information as this develops. Now, bruise management is complex and not easy. There is a lot involved and numerous variables to manage at a given time. But to simplify it, minimize impact, lessen tuber susceptibility, and all of this will ultimately decrease bruise. Additional resources can be found at the website on the slide, or feel free to email me at the address provided. Thanks to the Idaho Potato Commission and the Northwest Potato Research Consortium for funding of these projects. We look forward to hearing any questions or comments you may have. Thank you.